ENVI Classic Tutorial: Atmospherically Correcting Hyperspectral Data Using FLAASH. This tutorial provides an introduction to using FLAASH to atmospherically correct a hyperspectral image. We will display the radiance image, apply an atmospheric correction, and examine the results. The image used in this exercise was collected by the Airborne Visible Infrared Imaging Spectrometer AVIRIS sensor, which is operated by NASA. The sample image covers a portion of the Jasper Ridge Biological Preserve located in the eastern foothills of the Santa Cruz Mountains at the base of the San Francisco Peninsula. In the available bands list, right-click on the image and select Load True Color. You may recognize several features in the scene, including a vertically oriented lake in the top center of the image, various types of vegetation in the left side of the image, and urban areas in the right side of the image. This image is a standard AVIRIS data product that the NASA Jet Propulsion Laboratory processed. It contains calibrated at sensor radiance values that were scaled into 2-byte signed integers. Right-click in the image window and select Z Profile Spectrum to display the spectral profile plot window. Move the image box around the image and note how the shape of the radiance curve automatically updates in the spectral profile window. Right-click in the image window and select Pixel Locator. Move the pixel locator so that you can see it and the spectral profile window at the same time. In the pixel locator, enter 366 and 179 in the sample and line fields respectively. Click Apply to center on this pixel location, which illustrates some of the common atmospheric features often seen in hyperspectral data. Click and drag the cursor in the spectral profile window along the radiance spectrum and locate the water vapor absorption features at approximately 760, 940, and 1135 nanometers. Note also the opaque atmospheric regions around 1400 and 1900 nanometers where virtually no signal is recorded at the instrument. You can also see a common carbon dioxide signature that consists of two absorption features near 2000 nanometers. From the ENVI Classic main menu bar, select Spectral and FLAASH. The FLAASH Atmospheric Correction Model Input Parameters dialog appears. Click Input Radiance Image. Select the image file and click OK. The input radiance image consists of 2-byte signed integer values. For FLAASH to compute the atmospheric correction, these data values must be converted into floating point radiance values. In the next few steps, we will restore a scale factor file that will convert the values to floating point. In the Radiance Scale Factor dialog, select the Read Array for scale factors from ASCII file radio button and click OK. Select the TXT file and click Open. Accept all of the default values and click OK. The 1998 AVIRIS scale factors are 500 for the first 160 bands and 1000 for the remainder. In the FLAASH Atmospheric Correction Model Input Parameters dialog, the default path and file name for the reflectance output are displayed in the Output Reflectance File field. In the Output Reflectance File field, type the full path of the directory where you want to write the output reflectance file. For the file name, we will type Jasper Ridge 98 AV_flash.img. To navigate to the desired output directory before defining the output file name, click the Output Reflectance File button. In the output directory for FLAASH files field, type the full path of the directory where you want to write all other FLAASH output files. You may also click the Output Directory for FLAASH Files button to navigate to the desired directory. In the root name for FLAASH Files field, type a root name that will be added as a prefix to the FLAASH output files. In the next step, ENVI Classic will automatically add an underscore character to the root name that you entered. FLAASH output files consist of a column and water vapor image, cloud classification map, journal file, and optionally a template file. All files are written to the FLAASH output directory and the root name is added as a prefix to the individual standard file names. Click the Restore button located on the bottom right of the FLAASH Atmospheric Correction Model Input Parameters dialog. Select the TXT file and click Open. This file provides some scene information for the AVIRIS image along with FLAASH model parameters. Click Advanced Settings at the bottom of the dialog to explore the advanced options that are available. The parameters in the Advanced Settings dialog allow you to adjust additional controls for the FLAASH model. The default setting for automatically save template file is yes, and the default for output diagnostic files is no. While you may find it excessive to save a template file for each FLAASH run, the template file is the only way to determine the model parameters that were used to atmospherically correct an image after the run is complete, so it is important to be able to access it. Click Cancel to dismiss the Advanced Settings dialog. In the FLAASH Atmospheric Correction Model Input Parameters dialog, click Apply to begin FLAASH processing. You may cancel the processing at any point, but be aware that there are some FLAASH processing steps that cannot be interrupted, so the response to the cancel button may not be immediate. When FLAASH processing is complete, the output reflectance image, column water vapor image, and cloud classification map are added to the available bands list. Click Cancel in the Atmospheric Correction Model Input Parameters dialog to dismiss the dialog. Examine then close the FLAASH Atmospheric Correction Results dialog. From the available bands list, right-click on the reflectance file you just created and select Load True Color to New. The image is loaded into a new display group. Right-click in any of the two image windows and select Link Displays. The Link Displays dialog appears. Ensure that display number 1 and display number 2 both say yes and click OK. Right-click in the image window for display number 2 and select Z Profile Spectrum. In the image window for display number 2, click and drag around the image and note the shape of the reflectance curves. Note that some bands in the reflectance image have been designated as ENVI Classic bad bands and are not displayed in the plot window. The bad bands list in the ENVI header file is automatically set by FLAASH according to the strength of the reflectance signal. In the Pixel Locator dialog, enter 366 and 179 in the sample and line fields respectively, and click Apply. Compare the shape of the radiance curve with the shape of the reflectance curve of the same pixel location. This is one way to verify that the atmospheric correction was successful. Thank you for watching.